Okay, hello. These are the solutions for assignment 2. Number 1, for the following, find the angle theta. 1 point each, or 1 point, then 2 points, then 2 points. So first one here, we're given sine theta equals 5/10. First thing I'm going to do is reduce that fraction to 1/2. Then I'm going to take the inverse sine, or the arc sine, of both sides, and plugging that into my calculator exactly as is gives me 30 degrees. For the second one here, the cotangent of theta equals 7/3. I can't really do anything with the 7/3, but I can do something with cotangent of theta. I know that the cotangent of theta is equal to 1 over the tangent of theta. So I'm going to go ahead and make that substitution. So 1 over tan theta is also equal to 7/3 then. And I have one whole fraction equal to one whole fraction. I don't have split fractions on either side, so I can go ahead and flip both. A little bit of a shortcut here. So I end up with tangent of theta over 1 equals 3/7. And we don't actually really have to write the over 1 here, because the tangent of theta divided by 1 is still just the tangent of theta. So now we have the tangent of theta equals 3/7. I'm going to go ahead and take the arctangent, or the inverse tangent, of both sides to find theta, and plugging that into my calculator exactly as is gives me, let's call that 23.2 degrees. For the last one over here, the secant of theta is equal to 1 over 4/8. So I'm going to deal with this right-hand side first, simplify that a little bit. 4 divided by 8, well, that's just 0.5. And 1 divided by 0.5, well, that's just 2. Similar to the previous one, I know that the secant of theta is equal to the 1 over the cosine of theta. So I'm going to go ahead and make that substitution on the left. And at the same time, I'm just going to write 2/1 here. 2 divided by 1 is still just 2, so I really haven't changed anything. Just changed how it looks. And similarly to the previous question, I have a fraction equals a fraction, so I'm going to flip them. I get the cosine of theta is equal to 1/2. Take the inverse cosine, or the arc cosine, of both sides, and I get theta equals 60 degrees. So that was question 1. Question 2, solve the triangle. Just find all angles and side lengths. So first I'm going to go ahead and find the last missing side length here. I'm going to call that side A, and I'll call this angle A, and I'll call this angle B. So those are the 3 that are missing. So side length A, I'll find this using the Pythagorean theorem. So c squared equals a squared plus b squared. I'm solving for a here, so I get a equals the square root of c squared minus b squared. And plugging in my values, I get square root of 50 squared minus 40 squared. And this should be equal to 30, if I'm not mistaken, because this should be just a special triangle. But plugging in my calculator, just to be sure, nothing wrong with doing this. Yes, it is 30. So A equals 30 is one of our answers here. So now we can go ahead and solve for B or A, doesn't really matter which. I'm going to go ahead and solve for angle A, and I will go ahead and use cosine. So I will say that the cosine of A is equal to, now this is the adjacent over the hypotenuse, so this is 40 over 50, and taking the inverse cosine of both sides, I get A is equal to the arc cosine of just 40 over 50. Now, of course, you could reduce that fraction or turn it into a decimal, doesn't really matter. Up to you. And here in my calculator, I am punching these in very quickly, and I got, let's round that to about 37 degrees. And lastly, we know that all the angles in a triangle add up to 180. So I have my 90-degree angle plus my 37-degree angle plus the angle B, which means that when I subtract 90 from both sides and when I subtract 37 from both sides, that means that my B has to be 53 degrees, of course. And there we go. That is the whole triangle solved. Question 3 here. Solve the triangle. Find all angles and side lengths. So let's go ahead. We are going to need to find this angle I will call A and its corresponding side length. We are also going to need to find the hypotenuse, which I will call C. And that's all. That is all, really. I'm going to go ahead and find C first. Why not? I'll use sine. The sine of 70 degrees is going to be equal to the opposite, in which case this is 70 over C. I'm going to multiply both sides by C. So I get C sine 70 equals 70. Now I'm going to divide both sides by sine 70. And I get C equals 70 over sine 70. And that gives me a side length of about 74.5 meters in this case. We are given units of meters. Okay, so now we can go ahead and let's find angle A. Again, we know that 180 is equal to the 90 plus 70 plus angle A. So we're going to get 180 minus 90 minus 70 equals A. So A equals 20 degrees. Nice. And lastly, I will find side length A using tangent. So I will go ahead and say the tangent of the 20-degree angle I just found. And this is equal to the opposite, which is A, over the adjacent, which is 70. So I will multiply both sides by 70. This will give me, and I'm going to rearrange this here and write A on the left. A equals 70 tan 20. And that gives me 25. And let's say again 0.5. And of course, our units are meters. So that was the full assignment. However, we do have a bonus question down here. given the diagram on the left as a reference, can you use only sine law to solve this triangle? Let's go ahead and try quickly. See what we get. So first, let's solve for this angle here. I will call A. I will say that sine A over side A equals sine C over C. So I get sine A, of course, we're looking for that. A is 34. This is sine 90, and that's just going to be equal to 1 over 70. So multiplying everything by 34, I get sine A equals 34 times sine 90 over 70. Now, if you want, you could also say that the sine of 90 is just equal to 1, and simplify this even further, and say that the sine of A is equal to 34 over 70. I'm going to take the inverse sine of both sides. And this is going to be very close to 30 degrees. So 34 divided by 70, 29.1. So A equals 29.1 degrees. Okay, great. We got one of the angles. And so now moving on to find either side length B or angle B. Now we are asked to only use sine law to solve this triangle. So let's go ahead and say that we are looking for the angle first. So I have sine B over B is equal to sine C over C. I'm just using C because we know both the angle and the side length exactly. They're not rounded, so I like to use those numbers whenever I can. And plugging in, we get sine B over B equals sine 90 over 70, not 34. And here we have a single equation with two unknowns, and you can go ahead and set up a second equation for this and say that sine B over B equals sine A over A. So again, sine B over B. And plugging in, we get the angle we just got, so sine 29.1 over 34. And if we go ahead and solve this for B, we will get B equals 34 sine B over sine 29.1. And then we can sub that into our equation over here. I'm going to change the color of this stuff. So now I will say that this goes in here. And now I will say that I have sine B over 34 sine B over sine 29.1 equals sine of 90 over 70. And if you go ahead and carefully expand the brackets and simplify everything down, you'll notice that the sine b's actually end up canceling out, and we're left with an equation with no variables. So all of that work was kind of pointless. So no, in this case, you cannot only use sine law to solve this triangle. You do need just a little bit more. So that was assignment 2. Thank you for watching. If you have questions, please email me or ask me in class.